Hello, everyone, and welcome back to the FUNWAVE application on the FUNWAVE HPC Portal. In this tutorial, we will focus again on the third tab of our simulation workflow, the Inputs/Outputs tab, and more specifically, we'll focus on this sponge layer section. Here, you will find the variables that allow you to define different types of sponge layers along the boundary of your simulation. This is the fifth video in our FUNWAVE Portal video tutorial series. If you haven't already, check out the other video tutorials on this portal application to learn more about previous sections in this workflow. Also, don't forget to check out the comprehensive FUNWAVE Wiki for more information about the model and its parameters. Now, in FUNWAVE, we currently have a mixture of 3 sponge layers available in the model: diffusion, friction, and direct. There are benefits of using one sponge versus the other, and I will just share briefly what some of these are, and for the rest you can read up on the wiki or refer to the references that are provided on the wiki as well. So these sponges are exclusively for the boundary of your numerical domain. And down here, you can define the width of the sponge layer on the west, east, north, and south boundary of the grid. And these directions are relative to the FUNWAVE grid and not geographically oriented. Also, the width of the sponge layer is specified in meters, not in the number of grid points on the grid. So for each particular type of sponge, there are some additional variables you'll want to define to specify the strength of that sponge. So for example, if we check on the diffusion sponge, the diffusion coefficient variable appears with a default value of 1. Similarly, for the friction sponge, there's the friction coefficient variable. And for the direct sponge, there are 2 variables that appear, and those are the decay rate and the maximum decay rate. Default values are provided for all of these variables. To learn more about these sponge layers and their associated parameters, you can always hover over that info icon or click on any of these to be redirected to the wiki. And if we do that, we'll be redirected to this sponge layer page. And here you can find the details about those variables and make adjustments to them as needed for your specific modeling application. Now, in general, each modeling application will have different needs for individual sponges or possibly a combination of sponges. So for example, the direct sponge type by itself is not very efficient across a domain that has highly variable bathymetry, such as if the sponge were traversing from a deep water to shallow water in a 2D simulation per se. And oftentimes this can actually cause instabilities in the model when that is the case. This effect itself is because the strength of the sponge layer, of the direct sponge layer, is inversely proportional to the water depth. To compensate for something like this, you can apply a friction sponge type that can be used in combination with the direct sponge to provide some additional dissipative strength at the boundaries of the numerical domain. Now, the exact combination, strength, and placement in your domain for each of these sponges will vary depending on your specific application. And this process is generally completed by trial and error. So please be patient and be curious. If you do have specific questions or concerns, you can send an email to the FUNWAVE community by subscribing to our email listserv. And you can reach that by navigating it to the wiki page. On the main page of the wiki, if we scroll down here, we do have a subscription service that you can apply to or submit your email to. So After selecting a sponge layer or multiple sponge layers to use in your simulation, the next step is to define on which boundary the sponge layer will be placed and how wide to make that layer. Again, this width is in meters, not the number of points. Additionally, you cannot specify the width of individual sponge layers if multiple types are selected. So that means that each sponge layer will have the same width. Again, the sponge layers are placed on the boundary of your numerical domain, where the north, south, east, and west coordinates are relative to your domain. So in this example, for this two-dimensional simulation using an internal wavemaker placed near the western boundary, we'd want to maybe place a sponge layer on the west and east boundary of the domain. And let's say we'll have that be about 50 meters each. That's how we'd specify that. Now, it's a good rule of thumb to make your sponge layer the width of at least 1/2 the wavelength of your input conditions. And this practice generally helps minimize reflections in the domain from that numerical boundary. Now, altogether, there is a lot of variability in this section that is project or application specific. So we do recommend reviewing those materials on the Wiki page to gain some more context and details associated with these sponge layers and how best to apply them for your specific modeling purposes or application. So this concludes our brief tutorial on the sponge layer section of the input and output tab of our simulation workflow on the FUNWAVE HPC Portal application. Remember to save your changes by clicking this red save button in the bottom right corner of your screen. And please do check out the FUNWAVE Wiki for more information and details regarding this workflow and regarding this section in particular. If you do have more complex questions, you can always contact us via email as well. Happy modeling!